All right, in this example, we're going to be talking about how do we deal with the slant asymptote, right? And we know a slant asymptote is going to happen when our power differs on the top by 1 over the bottom. So happens when the degree in the numerator is higher than the degree in the denominator by 1. We're going to need to actually divide. So a couple ways that we can do this. Because it's a linear, we can do synthetic division to divide into this. Or sometimes you're going to have to do long division because it's not a linear. You got to divide it like you have a quadratic here and a cubic here. So we'll do both real quick. That if you remember, synthetic division is you're taking the denominator, or what you're dividing by, and you're finding the solution for it, which is -1. And then we have our coefficients. And so we're going to take 2, 6, -2. And then we've dropped this down. This starts off the whole process. And so that's going to give us a 2. We multiply and we combine. We multiply and we combine. And then this is our remainder. So this is what we're getting as a result. So remember that you're taking an x to the second, you're dividing by an x. So our power should be an x. So it's 2x plus 4 plus or minus, and we'll do plus a -6 over x plus 1. That's how we treat our remainder. Okay, so that's one way to do it. I'm going to show you the long division, and we're going to get the exact same result. That if I were to do long division, we would take x plus 1, and we would do 2x squared plus 6x minus 2. And we're going to try to match this. So what are we going to multiply x by to get 2x squared? And I'm going to put it the second term in. So we're going to multiply it by 2x. So we distribute. We have a 2x squared plus a 2x. And then just like on any division, we subtract that. So I'm going to change their signs to subtract them. That goes away, which is what's supposed to happen. This combines to make a 4x. We drop down the -2. Right, so there's the 4 kind of matching this. And then we multiply, we're going to multiply x by to get 4x. We're going to multiply it by a +4. So that's going to be a 4x plus 4. And then again, with any division, we subtract them. So that goes away and we're left with a -6. And there's our remainder. So plus a -6 over x plus 1. All right, so when we take this and we're doing the limit, and let's say we're just doing the positive side of this, limit as x approaches in positive infinity, we manipulated it into this, right? So this becomes a 2x plus 4 plus a -6 over x plus 1. All right, so if I do the limit, I'm plugging it in. So if I plug it in, I'm getting 2 times infinity plus a 4 plus a -6 divided by an infinity. Right, so this is going to be approaching 0. This is just a 4. That's the piece that matters, is that 2 times infinity is a positive something very large. Right, and then if we did the other side, as x approaches negative infinity, we got the exact same thing. 2 times x plus 4 plus -6 over x plus 1. We have it now at 2 times negative infinity, negative values, plus 4 plus a -6 over this time negative infinity, which isn't going to matter because this whole thing is going to be approaching 0. Doesn't matter if it's positive or negative. And then that's going to be pretty insignificant when you have a negative infinity onto that. So our overall end behavior, or our limit as x approaches negative infinity of this, would be negative infinity to the left, and to the right, positive infinity. So visually, we would have something going up, something going down. We'd have an asymptote in there. And so we'd have these other things that we might have, like the graph might kind of come up like this and down like this. But that's not what they're asking for. They're just asking for kind of the end behaviors when you're talking about these types of limits. So quick summary is when the denominator is bigger, so if this was switched around, Your pre-calc idea is that your horizontal asymptote is going to be at 0. So if you have something like this, if the powers match, then you're just really taking the leading coefficients is what's going to happen. Now, these are the pre-calc ways of getting your answer before you do the calc justification. Because remember, the calc justification is that if you're looking at this and you're like, hey, the powers match. I know it's just going to be leading coefficients. So my horizontal asymptote is going to be at 4. But the calc is always, we have to plug in a value. And so you can't have infinity over infinity and then talk about which one's moving faster. So we have to manipulate it, right? And at some point, we have to actually replace and plug in, and we need to have our math agreeing and justifying that we get a value of 4. All right, so, but I always take a pre-calc look to it and get an idea what my answer is going to be, and then I'll justify it with the calc. So power on the bottom, bigger, y equals 0. Powers match, it's just the leading coefficients. So this would be a 2/4 equal half. And then if your power on the top is bigger, it's going to depend on how much bigger. If it's going to be bigger by 1, then you're going to need to divide and then do the math and then plug it in. And then you have vertical asymptotes, which have nothing to do, just to kind of throw that connection in, that vertical asymptote is not the same idea as horizontal asymptotes or slant asymptotes. Vertical asymptotes are exclusively going to be by what kind of domain issues you have, which are going to be your factors coming from the denominator. It's going to lead you to your domain issues, right? And if it doesn't simplify out, those are holes. And if they remain, then they're going to create vertical asymptotes, which is not connected to this. So don't try to throw it all mixed together. And then our next problem, we're going to be talking about this same kind of idea, except it gets a little bit more complicated when you have a square root mixed into either the numerator or the denominator.